Today, we are going to explain a model based on dynamic stabilization. It works by vibrating the pivot, and the pendulum will oscillate upside down.
The model consists of the DC motor and the crankshaft mechanism. This is the pivot is directly and a pendulum indirectly.
In a simple pendulum, when we take it to a mean extreme position, it comes back to the mean position. This happens because the mean position has the minimum potential energy.
When we put the pendulum upside down, it will come down due to gravitational force and produce torque.
When we start the model, the as you can see, the pendulum oscillates upside down.
The inertia of the pendulum is much more greater than the frequency, so it will make the frequency into restoring force.
And there are vast applications of this project. It is used in self stabilizing robots, in space launching self balancing systems, as well as non linear research options. It is also used in advanced robotics.
A question arises: if we decrease the angular frequency, will it work? Yes, answer is yes, it will work, but practically not because we have to increase the amplitude.
Here, the formula says that this term is supposed to be greater than 1. Then only the stability will occur. So, if we decrease omega, we'll have to increase amplitude. But increasing amplitude isn't practical, so that is why we focus on increasing the frequency. Physics teaches us that impossible is not always impossible. It depends on the frame from which we view it from. Thank you.
Thank you.
My project is about the rotational motion of a rigid body. The phenomena of physics in this project is quite familiar with us every in our everyday lives. We see the rotational motion every day. Example: the rotating of a wheel of any vehicle, the ceiling fan rotating around every time. The rotational motion is basically a rigid body moving around its axis without changing its shape or position. It is very useful and a very fundamental concept of physics in our daily lives. In this phenomena, we use angular displacement, angular velocity, and so on. The angular displacement is the angle between which the position of the rigid body changes. For example, like it rotates. For example, we put a rod in between and any other rod in the side of it. We see it rotating without changing its middle axis. This was our project, and this was our model.
And this is our rod which will be placing in middle and it will be rotating. So we'll show you that.
This
Conclusion motion. Rotational motion is a rigid body and is one of the most important topics in physics. It explains how the objects rotate under under the influence of torque and how quantities such as moment of inertia, angular velocity, displacement, and many more. It gives rotational motion. This concept has numerous applications, as we have already told you. So, it rotates from a fixed axis. Thank you.
We are presenting a model on a green energy fusion city.
This model demonstrates the principles of physics, which is energy efficient and sustainable and eco-friendly. As the need of electricity is constantly increasing and fossil fuels are constantly decreasing, there is a need of essential conservation of energy and utilization of renewable sources of energy. So this model demonstrates that. Dynamic wireless charging rod. In the system, copper coils are embedded inside the rod, and as an electric vehicle moves, the electric energy is transmitted to the vehicle wirelessly due to electromagnetic induction. The bulb glows here to show that the vehicle is charging. Helical wind tubule. The tubule rotates due to the kinetic energy of the wind. This rotation motion drives a generator which converts mechanical energy into electric energy using electromagnetic induction. Traffic sensing smart street light. Instead of the lights remaining open in the time where there is no traffic, when the vehicle moves, the light is generated. This prevents the unnecessary waste of light and electricity. Solar tracking tree. Unlike fixing solar panels, this system automatically rotates where in the area of maximum sunlight. The uses of this model are it is sustainable development, renewable sources of energy are used, infrastructure is improved.
So today we have made a telescope model. So this is a telescope. So this is the tube of the telescope. This is the lens we have used. This is the eyepiece. So from here, if we look, we can combine these two lenses and we can see distant objects clearer and nearer, and like celestial bodies like moon, planets, and stars we can use. And this was first, the telescope was first patented by Hans Lippershey, and in 1608 it was improved by Galileo Galilei.
Usually, LEDs convert electricity into light, but a photodiode converts light into electricity. When photons, energy higher than silicon band, which is 1.11 eV, strike the metal surface, it releases electrons from the silicon band. Here you can see we have attached the LED and photodiode in a constant angle and distance. If Good morning. My name is Hannah Ephraim.
Good morning, I'm Janvi Tikia.
We are from class 12C and we're here to present a project studying current variation with different wattage of bulbs and distance.
Current electricity is one of the most widely used fields in physics. The power that is delivered to our appliances depends on current, which further depends on the voltage, resistance, and the length of the wire.
This is our circuit. So this is an breadboard which we use to connect the circuit, and this is a 9-volt battery, and these are jump wires used, and this is an LDR which is actually used to measure the current, and this is a multimeter which will be connected to the wires so that we can measure the current as well, and this is a box in which we have kept the bulb of different watts.
Our experiment is divided into two parts. Firstly, we are measuring the variation in current with different wattages of bulb. Firstly, we have put 3 wattage of bulb. Now, when we connect these to the two terminals of the multimeter, we'll get the variation in current, which we will further put into our Python code and get the graph of variation in current.
So our first experiment in which so our second experiment in which we keep 1 watt of bulb which is 7 watts, and we change the distance from 10, 20, and 30 to measure the current and how it changes with distance.
The applications of this experiment is used to prove Ohm's law and use them in circuits in our daily life. It is used in automotive vehicles, in batteries.
And we also use it to learn how to build circuits and keep it safe, and also use it wisely for the environment.
Thank you.
In this model, we have used three coils: 40 turns, 50 turns, and 60 turns. And a permanent coil is used of 60 turns, which will power all three of them. It is directly connected to the positive terminal of the battery eliminator, and the other end is connected to a transistor, which converts DC current to AC current. As DC current can't directly transfer the power without any physical wires. And the main concept of this project is that to flow the make the current flow wirelessly, and some of its applications are wireless mobile charging and some medical implants like rhythm creator in some people's hearts. Like it creates a rhythm that like batteries can't be replaced every time surgically, so it can be charged wirelessly. Thank you.
Actually, it is depend on EMF, where in which we uses a two to 8 transmitter, um, which switches the current into the transmitter coil, through which the magnetic field and the current changes, and IMF is induced. And this concept is given by Sir Faraday, and its formula is minus dq by d5 by dt, and minus charge is the direction of the current.
A liquid lens is a lens formed by a liquid drop that bends and focuses light due to refraction. The aim of our project was to find the refractive index of water and understand its measured the focal length of a convex lens, which was 19.65 centimeter. Then we placed the convex lens on a plane mirror and we introduced a thin layer of water between them. The new focal length was measured as 30.64 centimeter. Using these values, we calculated the refractive index of water. Our experimental refractive index was found to be 1.35, which is very close to the accepted value of 1.33, giving us a percentage error of only 1.5%. In conclusion, our investigation showed that the liquid lens method is a simple and reliable way to determine the refractive index of water. It also demonstrates the principle of refraction and its applications in lens design, optical research, and educational demonstrations. Thank you.
This particular resistance, what is the value of this resistance? 0.5. How do you know? It's resistance. How do you know it is 0.5? Suppose I take a box and I mix this one, and this one.
Ma'am, from the color and the strips present on it.
Yes, from the color coding, right? And so can you tell me the the last strip? Can you tell me what is the color and what is the value of it for this resistance?
Ma'am, the last strips is red in color, and ma'am, I don't know.
When you're given a resistance and you see there is some color coding, and you know that there is a color coding concept and a value assigned to it, you can just Google and find out how different colors are given a particular number and how we calculate the value 0.5. Okay. So the teacher tells you this is 0.5, and you should think, why is it 0.5? What can I do to find out whether it is 0.5 or not? Why not check it myself? What if the teacher has overlooked something? I should try to find it out myself, right?
So I have made an eddy current braking system, which is basically uh, a braking system where there is no physical contact, so the parts don't wear out as fast as a normal braking system. Now this works when the conducting acrylic disc rotates at high speed and a strong magnet is put close to it. The magnetic fields interact with this, and they create a circular electric current, which according to which is called as eddy currents. These currents, which are circular currents,
What is the basic use of eddy current?
uh, um, basic use of eddy current is one.
Application of eddy current.
Some the application of eddy current is that it can. This is one of the applications of eddy current where it can be used as a braking system.
As a braking system.
Yes.
Is it a necessary evil?
Ma'am, yes, ma'am, you need it. Everything is a necessary evil.
No, everything is not necessary evil.
Ma'am,
Everything is not evil. Is eddy current a necessary evil?
yes, ma'am.
How?
Ma'am, if it wasn't there, ma'am, it would be harder to stop high-speed trains and roller coasters.
That's the answer. So it isn't necessary, right? It is opposing but it is necessary. Otherwise, you will not be able to stop your cars, your engines, your machines, and so on. And it has got great application in industrial use, right? Please show them.
We should
Show how it works.
research well, and it's a very, very good concept.
Ma'am, this works when
Sir, our model is based on mutual induction by a self-designed transformer, and one is on Kirchhoff's law of voltage.
Mutual induction is a phenomena in which the primary coil induces electromotive force on the secondary coil by the help of uh, Faraday's law, and it was discovered by the Michael Farad.
In 1831, he discovered this law, and this law basically works on the principles of the electromotive induction. We can turn on the model by this. Here we have a self-designed transformer.
Design transformer.
We provide a
Use here. What is this?
this is a board. Here it is a transformer,
Okay.
and the battery is provided of 220 volts, and the transformer will convert it into a safe battery voltage of 12 volts,
How and why?
and by transformer, by the
What is the physics?
by the law of Faraday's law.
What's this Faraday's law? Step down. Step down transformer.
Down.
So it will use mutual
Mutual
induction
induction
from one coil to another, right?
20 does from AC does
gets converted to a safe volt of 12 volts.
Yes.
Then one of our primary coils will get charged, and it will induce.
Primary coil?
Yes, ma'am. And due to the
How
charging,
many turns on it?
I guess about more than 100. I guess
and which one has
Did
more
you wind it
turns?
up or somebody provided it?
some of this I've got from somebody.
Huh?
I've got this from somebody.
You have you done the winding yourself?
No, I haven't done the
You
value.
can sit yourself. What
I
is
can
it?
do
I
it.
tried
Take
it.
an iron rod and just go on. Keep on counting 1, 2, 3, 4. Then you know exact number.
Exactly.
So you should always know the exact number of your primary and secondary.
Second. Then it can step down or step up, you can say.
And the primary coil will
How
provide.
how does it depend upon the number of turns?
It is directly proportional to the number of turns.
So you know
The mutual inductance.
actually
Yes.
turning up yourself. How much current is flowing through the primary coil in your circuit?
Very much.
Did you
You can
measure?
calculate?
Then can measure it.
I measured the
Yes. Measure it. Okay.
yes.
Multimeter you can break.
Secondary coil is this one. How many turns?
This is a plastic goblet. The primary coil will produce a magnetic flux due to which, in the influence of that magnetic field, it will induce an EMF on the other secondary coil. And when I'll put it here, the LED bulb will start to glow.
What is this?
Here's the resistor.
No, this is not a
No, it's not
resistor.
the resistor. It's a diode.
Oh, sorry.
It's a diode, yeah? How do you know it is not a resistor? How do you know it is not a resistor? You're wearing a blue shirt, he's wearing a green shirt. Are they different?
Yeah.
So look at the way it looks like. Look at the resistance lying on the table. Pick it up. Place next to it. Are they identical?
Oh, they are different.
Cannot be resistor.
Different.
Value, even if the value differs, the way a resistance looks like, the diode doesn't look like that. And in this diode, there is this triangle and then there is this line. What does the line mean?
Value cannot
Not last chapter.
They are not resistor. Junction
In
diode,
junction,
they
they
don't
don't
have.
know. So one thing, your last chapter, class 12, 11?
Yes.
12. So last chapter will introduce you entirely to a PN junction diode. This is the symbol. This is the symbol of the diode. So you can remember this part and upgrade your knowledge when you reach the last chapter. Then you come to know how this PN junction diode is playing an important role in this particular circuit.
Good morning, judges. I'm Jebin, and this is my partner Joshua. And it's a model, refractive index of a prism in different liquids. When light moves from one medium to another, it bends due to a phenomena. When light moves from one medium to another, it bends due to a phenomena called refraction.
So here we are putting the prism in different liquids. So we are putting the prism in different liquids such as air, vegetable oil, sugar solution and water. So
Sugar solution, water, air. This is which one?
Vegetable oil.
Which vegetable?
Soybean.
Soya.
light bends the most in air due to a large refractive index, and in different liquids with higher refractive indices, like vegetable oil, the bending decreases. And if the liquid matches the glass, the prism almost disappears.
Okay, so which was it going to disappear?
We are here representing the study of chemical reaction in ripening of banana. We'll be doing three different concepts. We'll be bringing up three different materials to test in three different types of bananas. We have raw banana, a ripened banana, and a fully ripened banana. We do starch tests, sugar tests, and protein tests to check which banana is very, very useful and it is good for us to eat.
So we have made a table for a study in which we have mentioned the changes which we have observed. In this, we can see that we have taken three types of bananas: raw banana, semi-ripened banana, and fully ripened banana. And by our tests, we can conclude that the fully ripened banana is very good for the human body. And we have tested these bananas on basis of starch, protein, and sugars. And we have concluded that many starch, proteins, and iodines are present in the raw banana, which is a good sign to consume for the human body. And in the chart, we can also see that in the starch test, we have used iodine solution and Benedict solution for sugar test, and in protein solution, we have used protein solution. So in these bananas, uh,
We conclude that each banana shows different variation, and that is what how we are used to consume them. Different ranging shows different types of bananas where we often use them. Thank you.
The project is about converting footsteps into electricity. As you have seen that Japan is upgraded in technology that it's converting footsteps into electricity. So I have presented some sample of it. These are piezoelectric plates which will convert footsteps into electricity, and this is Arduino UNO. In this I have done coding which display shows here, and this is mini breadboard in which all the connections are given there. This is battery connected to it. With the help of this, display is working. Like when we press our piezoelectric plates, it's generating electricity, and it's the code that is working on this display.
Its real life applications are so many. It can be used in malls, roads, concerts, and wherever the footfall is more. And it is very helpful in India because we have 1.4 billion of population. So it can be used as a renewable energy source instead of polluting the environment. It is very environment friendly and can bring a huge change in our society. Thank you.
This model is about tensegrity structure, and it is depends upon string and rods which is interconnected. It seems like its gravity is not acting on it, but it's actually acting. It is not connected directly, but it is connected by a string which you can see here. And this structure is a unique structure, and it was discovered by Kenneth Snelson, and the concept was given by Buckminster Fuller. This is very useful structure. During earthquake, it can absorb force.
So this is a project on human heart. Heart is a muscular organ that pumps blood to all parts of our body. Its size is of the size of our wrists. And there are four chambers of heart: left ventricle, right ventricle, left atrium, and right atrium. This is the oxygenated blood, and the blue one is deoxygenated blood. It travels through heart, and the left ventricle pumps the blood to all parts of our body. Thank you.
I make a science model of Chandrayaan 3, and it was India's third mission. Solar working model which takes the sun's light and stores it in a battery, and the battery makes the light glow. Rainwater harvesting is a process of to conserve the rainwater for later use. It helps us to save the water for the future use.
Model for farmers. This model shows how sensor can help farmers in to save their crops. In our village, when the animal like sheep enter the field, they destroy their crops. The farmers place a sensor near the fence, and when the animal like sheep come in the field, it will turn on and alert the farmers. This
So in this model, I've created a system which uses air sensors, buzzers, and LEDs to send a notification, sends a movement in the car if the car moves from the parking area. I'm going to speak about hydroelectricity. Behind the dam, the water is stored. After it flows through the pipes and then turns a turbine. Then the turbine runs a generator which produces electricity, and then through power lines it comes to a powerhouse and gives electricity, and to industries also. Hydroelectricity is electricity which produces electricity by water.
Topic of my science model is floating solar power plant. A floating solar power plant is a process where which solar panels are placed on the water such as lakes or reservoirs. They generate electricity by absorbing the sun's energy while floating on water.
A smart rain alarm system. It is used to detect rainfall and alert people by ringing an alarm. The system works on the principle of closed electricity circuit and conductivity of water. Rainwater contains dissolved salts and minerals in it, so it can conduct electricity. When water connects these two metal strips like this, the buzzer rings. So if when rain comes, it will just ring and alert us. Thank you. Topic is multiple solar energy. And I'm here to represent my model on hydraulic lift. A hydraulic lift is a machine that uses pressurized fluid to lift heavy loads. It lifts heavy loads. It operates on the Pascal's law or the Pascal's principle, which is a core principle and a component. This is my model for the hydraulic press. It works on the Pascal's law. Pascal's law states when the pressure is applied to a confined liquid, it is transmitted equally in all directions. In this game, the player has to move the metal loop in without touching the metal wire. If the loop touches the wire, the electric circuit is completed and the buzzer make a sound.
Drone is a UAV, unmanned aerial vehicle. It can be used for many purposes like photography in marriages and many other things like defense, DOD, etc. etc. First, we started with the frame. We got the frame from Amazon and then we attached four brushless motor that will create the spin for the motor. When the drone spin and the motors work, it generates lift. Due to this lift, the drone flies, and the weight of the gravity is cancelled, and the drone is lifted up. When the motors push the air downwards, which creates force on the ground, and it makes the drone push upwards. And to defeat air resistance, it has a very aerodynamic design. The components we used are these. The frame was an F450 quadcopter drone. The flight controller, which has all the gyro sensors and all the sensors that makes the drone work, is the Mamba 405. There are four brushless motors, as I mentioned. The battery is of 200 mAh, which gives it an approximate flight time of 10 minutes. And the firmware we used is Betaflight. These are the exploded view of the main components. First, the drone works by taking the input from the receiver, and then the receiver gives it to the flight controller, and the flight controller manages the speed of the ESC and motors. The physics behind the drone is like this. First, the lift is generated, then the weight gets cancelled, and aerodynamic resistance is opposing the motion that affects forward flight efficiency drag. This is the main view of the sensor. It has four main features. Sensor input. The MPU 650 provides gyro and accelerometer data for the altitude estimation. The PID stabilization, it's the real-time PID which manages the speed of the motors. Signal processing, it takes S-bus signal from the receiver which was coming from the transmitter and gives it to the flight controller in a readable manner which it can easily read.
This is the inside view of the brushless motor that we have used. Brushless motors has 3 wires. Only 2 of them are supplied at once, and when the other wire is supplied, the motor starts to spin anti-clockwise. The ESC we use are 30A continuous and suppose D short BAC, which is not required for a drone. This is the battery. The battery has a nominal voltage of 11.1. It has 3 cells, and it's lipo and energy. It has minimum energy. It gives us maximum energy, and the weight is very less. This is the wiring diagram of the drone. Thank you.
Today I'm going to show you. Good morning, director sir. Today I'm going to show you a very interesting science experiment called dancing raisins. For this experiment, I need a clear glass tumbler, Sprite, soda or 7-Up, and 5 to 6 raisins. First, I pour the soda into the glass, then I drop some raisins in it. After a few seconds, the raisins will start moving up and down. You know why does it happen? It happens because of the soda contains tiny gas bubbles. When bubbles stick to the raisins, it makes them light and they float to the top. When bubbles burst, it becomes heavy and they sink down. Then again new bubbles stick to them and they float to the top. This happens again and again as if they are dancing. Thank you. Today I'm going to show you my science model that is on the phases of moon. The different phases of the moon are the different shapes of the moon. The moon does not make its own light, it reflects the light of the sun. As the moon moves around the earth, different parts of it appears bright to us. New moon. The moon is between the earth and the sun, so we cannot see it in the sky. Waxing crescent. Only a thin, small curved part appears visible in the sky. The brighter part starts growing bigger. First quarter, half of the moon appears bright in the sky. It looks like a half circle. Waxing gibbous. More than half of the moon appears bright in the sky. It is going towards the full moon. Full moon, the entire face of the moon appears bright in the sky. Waning gibbous. After the full moon, the brighter part starts getting smaller. But more than half of the moon is still visible in the sky. Last or third quarter, again, half of the moon appears visible in the sky. But this is the opposite half from first quarter. Waning crescent. Again, only a thin, small curved part appears visible in the sky. But this is the opposite half from waxing crescent. Thank you.
I have made a working model to show how day and night occurs. This model works on the principle that the earth rotates on its own axis once in about 24 hours, which causes day and night. The sun gives us light. Now, here, this lamp represents the sun, and this globe represents the earth. We know that the earth rotates on its own axis. The part of the earth facing the sun gets light and therefore experiences day. On the other hand, the other side of the earth that does not get light experiences night. And as the earth keeps rotating, day changes into night and night changes into day. That's why we have day and night every 24 hours. Thank you.
Today I will explain my working model on seed germination. Seed germination is the process by which seed grow into a new plant. A seed remain inactive until it get right condition to grow. There are 5 stages on seed germination.
Today I'm going to explain my model, a mechanical robotic hand. A mechanical robotic hand is a model that works like a real human hand. It uses straws, strings, and cupboard to make the fingers bend and move. When the strings are pulled, the fingers bend and grip objects.
This is the human digestive system model. Uh, Digestive system breaks food into nutritious, that gives us energy and help us to grow. So here it goes into the mouth, then esophagus, then stomach, then the liver, pancreas, then small intestine, large intestine, rectum, and comes out through anus.
Welcome to my project. Today, we are looking at a strange mixture that mixes the everyday rules of science. Watch this. If I squeeze it with hard and force, it will turn into a ball in my hand. But the very next second I release it, it will turn into back into the liquid. This mixture refuses to follow Sir Isaac Newton's law, which says liquid should always stay the same thickness. Because it is turning from thick to thin, depending on the pressure you use, it is called non-Newtonian fluid. Thank you. And my model is called a doodling robot. A doodling robot is also called a art or scribble bot is a simple motorized machine that use vibration to draw random colorful pattern on paper all by itself. It is powered by a small battery and a spinning motor. It is realized on a
This is my model on global warming. Global warming forms when Earth is getting hotter. It happens because of pollution from cars and factories that release very harmful gases like CO2 and SO2. Due to this, glaciers start melting and water level rises. Some areas become very hot like deserts.
Today, I'm going to present my model of cross pollination by a honeybee. First, let's understand what pollination is. Pollination is the transfer of pollen grains from the anther part of a male flower to the stigma part of a female flower. This process helps us plants produce fruits and seeds. Here we can see there are two flowers and a honeybee. First, the honeybee will go to the anther to collect the nectar. While collecting the nectar, the pollen grains will stick to its body. Good morning. Today I'm going to explain my model about hydraulic lift. What is a hydraulic lift? A hydraulic lift is a machine that uh, lifts very heavy loads. Let me explain you.
Drip irrigation system is a smart way to water plants in agriculture. Now, I will explain. Water Water goes into the storage tank with the help of a water pump and goes down to thin pipe with tiny holes. Water drips slowly fall near the roots of each plant. This shows that the water is going drip by drip. There are many advantages of this method. It saves water up to 30 to 60% compared to surface or flood irrigation. It saves time, it saves electricity, minimize the weed growth, consistent soil moisture level, reduce plant stress so that the plant could grow more healthier and faster. It requires less effort and very low budget. This method is very useful for dry places like Rajasthan, Maharashtra, Gujarat, and other dry places.
Engineering is not about making work harder, it is about making work smarter. My working crane model demonstrates how simple machines such as pulleys can uh, lift heavy weight. These are widely used in shipping ports, factories, and large construction sites.
Today I am going to show you a simple science experiment on transfer of heat.
Then I started wondering what is heat? So, heat is a form of energy that can be transferred in three different ways. Number one, conduction. Number two, convection. And number three, radiation.
When we fill the bottle completely with water and cover its mouth with a tissue paper, then turn it upside down, the water did not fall out. This happens because the air around us pushes upwards on the tissue paper. This push is called air pressure. The air pressure from outside is strong enough to hold the tissue paper in place and support the water inside the bottle. So the tissue paper does not fall and the water stays in the bottle. Thank you. Today I have a magic experiment showing a blank white paper. Look, it's just a blank white sheet. But what if I use this magic solution? Apply the solution and the hidden message appeared. Wow, a hidden message appeared. Magic? No, it's science. I wrote the message with baking soda, then I used turmeric, and the hidden message appeared. Turmeric change color with baking soda. Thank you.
Today I will show you the science magic trick using the special kind of paper called litmus paper. Do you know liquids have secrets? Some liquids are acids and some are bases. The litmus paper is like a science detective. It changes its color to tell us what is liquid is hiding. Material needed: the blue litmus paper and red litmus paper, lemon juice, soap water, and the dropper or a spoon. Testing lemon juice. Take blue litmus paper. I will dip in lemon juice. The blue paper turns red. This means lemon juice is an acid. Acid turns litmus paper red. Testing soap water. Take red litmus paper. I will dip in soap water. Now see the magic. The red paper turns blue. This means soap water is base. Base turns litmus paper blue. So the science detective paper teaches acid turns blue paper red and base turns red paper blue. If the litmus paper does not change its color at all, this means the liquid is neutral, like a plain water. Thank you.
I am showing perspective illusions. This is an experiment because it shows how our eyes and brain work together. The floating illusions. You see a boy on the square pole floating and this ball floating in mid-air. If I tilt the sheet a bit, you see it is not. This experiment teaches us that our eyes see the vision, sends it to the brain, and the brain interprets quickly without even taking time. But illusions can make the brain to get a wrong guess. This is why it's called perspective illusions. Thank you.
For my experiment is called lemon batty. For this experiment, I am using lemons, coppernase, zingnase, wires, and an LED. The lemon juice is acidic. When the copper snail and zinc nails are placed inside the lemon, they react and produce a small amount of electricity. This electricity flows through the wires and make the LED glow. This experiment shows that chemical energy changes into electrical energy. Thank you.
My model is a water dispenser. It works using air pressure, gravity, and a straw. When the lid is closed, no air can enter the bottle, and a small vacuum inside the bottle that holds the water from coming out. Show you my fun science model that is smart water alarm system. Sometimes we switch on the water pump and forget about it. Then the water tank got full overflow, and the water got spilled down. As you know, the precious is water. I have made a solution to save it. Whenever the water tank got full, the alarm will beep loudly. Today I am presenting my fire alarm model. A fire alarm is an important device that helps people and protecting from fire accident. In my model, when the sensor detects a fire-like condition, going to tell you about my working model of a dam. A dam is a barrier that is built across a river to store water in a reservoir. It is useful for supplying water for homes, farming, and industries. It also produces hydroelectricity and controls floods. The principle of a dam is to use gravity and water pressure to hold back water.
Today, I'm here to represent my working model on rain harvesting. Rain harvesting means collecting and storing rainwater for the future. When it rains, the rainwater falls on the roof of the house. The water goes through a pipe into a filter. The filter removes dust and leaves. Then the clean water gets stored in storage tanks. This water can be used for watering plants, cleaning, washing, cooking, etc. The extra water gets stored in wells to support groundwater. With rainwater harvesting, we can save water, reduce water shortage, and keep the environment clean. Thank you.